Dear students, our today's topic is in 10th science, electricity, and today our concept is electric resistance. It is denoted by R. Now, what is electric resistance? Try to understand. Every material, as you know, is made up of atoms, and atoms have electrons in their extra nuclear part. Okay, suppose this is a material and these are its atoms, and these are the electrons in the extra nuclear part of these atoms. When we force a current or say charge, since generally charge is moving electrons, when we force these moving electrons or charge q through this material, what happens? Already electrons present in this material repel these electrons, and with the result this material tends to stop the flow of the charge through it. This opposition laid by a material against the flow of current through it is called as electric resistance. So electric resistance is the opposition laid by a material against the flow of current through it. Insulators have very high resistance, so current does not pass through them. Conductors have low resistance, with the result current passes through them easily. Now, we need a mathematical definition of electric resistance too. Yesterday in Ohm's law we have studied V is proportional to I and V is equal to IR, where R is the resistance of a constant of proportionality called electric resistance. This R is then equal to potential difference V divided by I. So resistance can also be defined as the ratio of the potential difference across the ends of a conductor to the current flowing through it. Suppose this is a conductor and it has potential difference at its ends V and current I is flowing through it. The ratio of its potential difference to the current V divided by I is equal to resistance of this conductor. And let's see the unit of resistance. The SI unit of electric resistance, or simply you can say, is shortly written like this in the honor of the scientist Ohm. Now we can be asked a question: what do you mean by 1 ohm resistance? Use this. R is equal to V by I. If potential difference is 1 volt, current flowing is 1 ampere, then R is equal to 1 volt divided by 1 ampere, that is equal to 1 ohm. So 1 ohm is the electric resistance of a material if at a potential difference of 1 volt a current of 1 ampere flows through it. Now, what are the factors on which resistance depends? Factors on which resistance depends. First factor is the length of the conductor. length L of the conductor. Now, how this resistance varies with the length depends on the length. Resistance is directly proportional to length of the conductor. Greater the length of the conductor, greater will be the resistance. If we half the length, make the length of the conductor by cutting it, make half its length, its resistance will be half. If we double the length, the resistance will also become double. Second thing, resistance depends on the area of cross section. Area of cross section, or simply you can say thickness. Thickness of a conductor. Resistance is inversely proportional to the area of cross section or thickness. If a conductor has greater area of cross section, more thickness, it will have less resistance. If we take a conductor of area of cross section 1 meter square, and then if we replace this conductor by another connector of the same material of area of cross section double the thickness, then the resistance will become half. If the thickness of the conductor increases, becomes double, the resistance will become half. And third is the nature of the material. Nature of the material. You know, gold is best conductor of current, electricity. It has least resistance. Since it is cheap, very costly, we have the cheaper next metal, that is copper. Copper is a better conductor, you can say best conductor in terms of the resistance and in terms of the cost. It has low resistance. Iron has greater resistance than copper. That is, the resistance depends upon the nature of the material. Thanks.